Hello, welcome back to the lecture series on Transport Layer. In this video, we are going to learn about TCP Overview Part 1. So let's look at the agenda. We are going to learn about the principle of operation of TCP. Then some of the TCP features will be discussed. After that, the numbering system of TCP will be discussed in this video. What is the principle of operation of TCP? TCP basically creates a virtual connection between two TCPs to communicate. Let's say we have a client side and a server side. Mainly we are dealing with client-server application programs which are in execution. So these are known as the processes. So in order to communicate between the client and the server, a path must be set up. This path is virtual in nature, and the path is set up by creating a socket, which is an interface between the application layer and the TCP layer. Similarly, a socket must be created at the server side as well. Now, we must understand that in order to communicate, this TCP is a connection-oriented protocol and it is a reliable protocol. Then how come TCP encapsulates itself into the IP and passes it to the other IP for host-to-host communication? Here in TCP, we have process-to-process communication. You know, this IP is unreliable, but TCP actually takes care of this reliability and connection. So TCP decides which packet to discard and which packet to accept by using the flow control and error control mechanism in the TCP layer without any regard to the IP layer. Now this TCP communication takes place in 3 steps. Number 1 is connection establishment by three-way handshaking. So let us see how the connection establishment is done by three-way handshaking. Let's consider that we have a client process working in this area and a server process working in this area. So the client process must have an active open TCP connection, and the server process must have a passive open TCP connection. What is the meaning of this? In order to initiate the process, the server must open the TCP connection, but it is passive in nature, meaning thereby that it is waiting for any connection from the client side. Now the client is active in the sense that it is the one who establishes the connection or initiates the process of connection to the server side. Now once the connection is established, and this is the virtual connection, let's see how it is done. TCP basically sends a sequence number of the data packet that it wants to send, and along with that, it sends a sequence sync packet. So this is the sync flag is set. The server, once it has received this packet from the client side, will send its own sequence number of the packet. Let's say it is 15,000. This is the sequence number. I'm going to discuss about the sequence number shortly. And it will acknowledge with the acknowledgement number 8001. Now, what is the meaning of this acknowledgement number? This means that TCP has received the segment with the sequence number 8000 from the client, and it is waiting for the acknowledgement which it has received 8000 plus 1. So here it consists of the acknowledgement packet as well as the sequence packet, and it uses one sequence number. Here also from the client side it uses one sequence number. Now this client then uses a sequence number 8000 as before and sends the acknowledgement from the server side. See, server side has sent the sequence packet 15,000, so the client side has to send an acknowledgement number plus 1 of the sequence number of that received by the server. So it is 15,001, and it is simply an acknowledgement packet. So it does not use any sequence number. So this is the three-way handshaking process, process 1, 2, and 3. So this way the connection gets established. Here A stands for the acknowledgement flag and S stands for the sync flag. Next process is the data transfer process. Let's see how it is done. As before, we have a client side here running one process and a server side running another application process. As before, this is an active open process, and this is a passive open TCP connection. The client should send the chunk of data with the sequence number. Let's say it is starting with 8001, and it is sending an acknowledgement packet. As before, it has already received the packet from server with the sequence number 15,000, so it is sending an acknowledgement 15,001. Here we have the acknowledgement packet plus the PSH flag set. So this PSH means the push flag, when the client is pushing its data to the server. Here, let's say the client is sending the data packets from 8001 to 9000 having this sequence number. So it is sending 8001. So this sequence number will be the first number of the data packet, and it will send the acknowledgement number. So since it has, in the earlier slide, I have shown that it has received the packet from the server with the sequence number 15,000. So its acknowledgement number will be 15,001. Here, there is the acknowledgement flag and the PSH flag. So A stands for acknowledgement flag and P stands for the PSH flag. PSH flag means the push flag. Now the server has not sent anything yet. So the client will send the next chunk of data starting with the sequence number 9001, and similarly it will send the acknowledgement number 15,001 and the data packet 9001 to 10,000. The server now will send its own sequence number, that is, it is 15,001, and acknowledgement number of 10,001, because it has, this means that it has already received data packet with the sequence number 10,000. So the data it is sending is 15,001 to 17,000 here, and this is simply acknowledgement. The client again can send a sequence number 10,000 and with the acknowledgement 17,001 because it has received the 17,000 packet number from the server. So it is sending again an acknowledgement, and this is the receiver window size, which we are going to learn later on with the 10,000 data. So this way the data transfer takes place between the client and the server. Next, there is the connection termination process. Once the data transfer takes place and it has been completed, the connection termination takes place. So this also uses three-way handshaking. As before, we have the client and the server and the active and the close, active close and passive close here. Previously, it was active open and passive open. Now it is active close, passive close. So here, the client will send the, let's say it is a sequence number X and acknowledgement Y. It will send a fin type of packet. So F means it is a fin type of flag, which means that it wants to terminate the connection. The server can send the sequence number Y and with the acknowledgement X plus 1 because it has received this X. So it is X plus 1, and again it will send the FIN plus acknowledgement packet. The client can again send the sequence number and acknowledges that it has received the sequence number Y. So it sends acknowledgement Y plus 1, and this is an acknowledgement packet. So once this is done, the 3 steps 1, 2, 3. So three-way handshaking is done to terminate the connection. Let us now look into some of the TCP features. TCP features consist of the numbering system. So the numbering system basically consists of byte number, which is the data byte that is being sent from between the two hosts, the client and the server. Then we have the sequence numbers, which are the numbers of the segment. Then we have the acknowledgement numbers, which defines that the packets or the segments have been received by the opposite parties. Next feature is the flow control features. Unlike UDP, here a flow control feature is there in TCP, and error control is also very strong in TCP, unlike UDP. And TCP uses a congestion control mechanism to control the flow. Basically, it looks into the congestion of the network. To avoid congestion, it has some policies, which we are going to learn later on. For the numbering system, it can use the value between 0 and 2 to the power 32 minus 1. Let's say we have, and it is a random number. Not necessary that it has to start from 0 or 1. So it is a random number. Let's say it is starting with 1055, and if it has to send 6000 bytes of data, then the last numbering will be 7044. So this is how the byte number is assigned. Next, we have the sequence number, which is the segment number. And this basically is the number of the first byte that is carried in that particular segment. Next, we have the acknowledgement number. It is the number of the next byte that the party expects to receive. All these numbering systems have been discussed in the previous examples. This acknowledgement number is also cumulative in nature. This flow control and error control mechanism uses the byte-oriented approach in TCP. The congestion control mainly takes care of the amount of congestion in the network. Let's look at the numbering system with a problem. It says that a TCP connection wants to transfer a file of 4000 bytes. The first byte is numbered 11001. You need to write down the sequence of numbers for all the segments if data are sent in 4 segments, and each should carry 1000 bytes of data. Let's look at the solution. Since there are 4 segments that are required, so we give the numbers as segment 1, segment 2, segment 3, and segment 4. Now, what should be there in segment 1? In segment 1, the sequence number, as it said, it starts with 11001. So we write down 11001. And what should be the range? The range should be 11001 to 12,000, because it says that each segment should carry 1000 bytes of data. The segment 2 will start with the sequence number 12,001, and its range should be from 12,001 to 13,000. Segment 3 should start with sequence number 13,001, and its range should be 13,001 to 14,000. For segment 4, we have sequence number that should start with 14,001, and the range will be 14,001 to 15,000. To summarize, in this video, we have learned about the principle of operation of TCP, various TCP features, and the numbering system of TCP. Thank you.